Have you ever wondered how your computer processes information? Well, that's where the Central Processing Unit, or CPU, comes in. It's the primary component of a computer, and it's responsible for most of the processing that happens within. The CPU is like a busy conductor, orchestrating a symphony of operations that make your computer function as it should. At its core, the CPU carries out the instructions of a computer program, performing basic tasks such as arithmetic and logic operations, as well as controlling input and output operations. It's a bit like a multitasking maestro, juggling numerous tasks at once and doing it all in the blink of an eye. Whether it's calculating the sum of two numbers or determining if one value is greater than another, the CPU is constantly at work, ensuring that your computer runs smoothly and efficiently. So, in simpler terms, you can think of the CPU as the brain of your computer. Now, what makes up this brain of your computer? Let's dive right in and break down the Central Processing Unit into its core components. These are the Arithmetic Logic Unit, or ALU, the Control Unit, registers, and cache memory. Each has a unique role in making sure your computer operates smoothly and efficiently. Let's start with the Arithmetic Logic Unit, often abbreviated as ALU. This is where all the magic happens, so to speak. The ALU performs all the basic arithmetic and logical operations that are part of any instruction. From simple addition and subtraction to complex multiplication and division, even logical operations like comparing two values, the ALU handles it all. Next, we have the Control Unit. If the ALU is the heart of the CPU, then the Control Unit is the brain. This is the part of the CPU that directs all the other components, telling them what to do and when to do it. The Control Unit fetches, decodes, and executes instructions, coordinating the work of the entire CPU. Then we have the registers. These are small storage areas that hold data that is actively being used by the CPU. Think of them like the short-term memory of the CPU. They provide a place for the CPU to quickly access the data it needs without having to reach out to the slower main memory. Lastly, we have cache memory. This is a small amount of very fast memory that is used to store frequently accessed data, making it readily available for the CPU. It's a bit like having your favorite cookbook open on the kitchen counter while you're baking. You don't have to go looking for recipes, they're right there when you need them. To wrap it up, the CPU is made up of several components, each with a crucial role in processing information. From the Arithmetic Logic Unit that does all the number crunching, to the Control Unit that orchestrates the entire operation, to the registers and cache memory that provide quick access to frequently used data. These components work together to ensure your computer processes information efficiently. First in line, we have the Arithmetic Logic Unit, better known as the ALU. The ALU is the heart of the CPU, the place where all the magic happens. It's like an incredibly fast and efficient mathematician, tirelessly performing calculations and comparisons at the speed of light. Picture the ALU as a mathematical wizard, tirelessly performing arithmetic operations such as addition, subtraction, multiplication, and division. But it doesn't stop there. The ALU also handles logic operations. These are decisions based on certain conditions, like determining if one number is greater than, equal to, or less than another. But how does the ALU know which operations to perform? That's where the Control Unit steps in. It directs the ALU, telling it which operations to carry out based on the instructions that it decodes from the software you're running. It's like a conductor leading an orchestra, ensuring each instrument, or in this case, each operation, plays at the right time. One crucial aspect of the ALU that we need to highlight is its speed. Remember, your computer performs millions of calculations and logic operations every second. The ALU is the workhorse that makes this possible, crunching numbers and making decisions at an unimaginable pace. It's like a grandmaster chess player, thinking several moves ahead and executing them all in a fraction of a second. But what happens if the ALU makes a mistake? Well, just like you and me, the ALU isn't perfect. It can make errors. But here's the good news. The ALU has a system of checks and balances. If an error occurs, it's flagged and the operation is rerun to ensure accuracy. It's like a vigilant watchman, always on guard for any slip-ups. So the next time you use your computer, remember the ALU. This little powerhouse is working tirelessly behind the scenes, performing calculations and logic operations at lightning speed. Without it, your computer wouldn't be able to do much of anything. Without the ALU, your computer wouldn't be able to perform the simple calculations or logic operations that it does every second. Moving on, let's explore the Control Unit and registers. The Control Unit, often considered the nerve center of the CPU, has a pivotal role in managing and coordinating all the computer's operations. Picture it as the traffic cop of the computer's highway, directing all the data and instructions to the right places at the right times. The control unit doesn't perform any actual data processing operations. Instead, it directs the system to carry out stored instructions. It does this by sending timing and control signals to other components within the system. It's the control unit that determines the sequence in which instructions are executed, ensuring optimal computer performance. One of the key tasks of the control unit is to decode instructions. Once decoded, the control unit can direct the operation to be carried out by the appropriate component of the computer. This could be the arithmetic logic unit, the memory, or even the input and output devices. Now, let's turn our attention to registers. Consider registers as the temporary storage spaces within the CPU. They hold data that is being processed, instructions that are being executed, and the results of these operations. There are several types of registers, each with its own specific function. For example, the accumulator register is used for arithmetic and logic operations. The program counter, on the other hand, tracks the sequence of instruction execution. The instruction register holds the instruction currently being executed, while the memory address register holds the addresses of instructions and data. In essence, registers are crucial for the CPU's functionality. They provide quick access to data and instructions, enabling the CPU to perform its tasks swiftly and efficiently. So, to sum up, the control unit and registers are fundamental components of the CPU. They work together to manage, coordinate, and carry out instructions, acting as the conductors of this intricate symphony we call a computer system. The control unit and registers are like the conductors of an orchestra, coordinating and holding everything together. Lastly, let's not forget about cache memory. This isn't just some obscure tech term. Cache memory plays a vital role in the functionality of your CPU, and by extension, your computer. But what exactly is it? Cache memory is a high-speed data storage component that resides inside the CPU. Its primary role is to store frequently used data so the CPU can access it more quickly than it would if it had to retrieve it from the main memory. So, just think of cache memory as your computer's go-to storage for data it needs to access often. But why is speed so important? Well, consider this. You're working on a complex project and you need to access a variety of documents, images, and other files. If your CPU had to fetch all this data from the main memory every single time you needed it, that would slow things down considerably. But with cache memory, your CPU can get to this data much faster, creating a smoother and more efficient computing experience. Now, there's a catch. Cache memory is limited. It can't store all the data the CPU might need, so it uses a process called caching to decide which data to store. This process involves algorithms that predict which data the CPU will need to access next, based on the data it's accessed in the past. In this way, cache memory is always ready with the right data at the right time. So, to put it simply, cache memory is like a small, super-fast storage area that holds the data your CPU is most likely to need. It's critical to the efficient operation of your computer, helping to speed up data access and enhance your machine's performance. To draw a real-life analogy, cache memory is like your computer's quick-access notepad, storing data that needs to be readily available. It's a small but mighty component of your CPU, and understanding its role can help us appreciate the complexity and brilliance of modern computing. So, we've explored the different components of a CPU and their roles. Let's take a moment to look back at what we've learned. The Central Processing Unit, or CPU, is the brain of the computer, executing instructions and performing basic system operations. Within the CPU, we have the Arithmetic Logic Unit, or ALU, which is responsible for carrying out basic arithmetic and logic operations. The control unit orchestrates the fetching, decoding, and execution of instructions. The registers store temporary data and instructions, while the cache memory provides high-speed data access to the CPU. Each of these components plays a vital role in the overall functioning of the computer. They work together to process data and run programs, turning lines of code into actions. By understanding these components and how they work, we gain a deeper insight into the incredible processing power inside your computer.